All right, well, welcome everyone. I hope we had a wonderful weekend and our study's going well. So our plan today, we're going to talk about this summary worksheet. I've got 5 questions I would like to do with you guys. Remember, I've said we will prepare you for things to expect in the test, if anything unusual. Nothing unusual, but just want to remind you, Raj, of a couple of skills here. So that's what we'll do first. Then what I would do is just like to float around and see how everyone is, okay? And then I will organise time to address questions, no doubt, that people have, whether it be there's questions in common or questions with small groups of people and so forth. And then that's up to you how you use your time when we get to that circumstance. So we'll just go through this worksheet quickly. This is what I've summarised during our last lesson, so just the conditions of the test. We've got the content there. I emailed a summary of the playlist that of all the recordings we've made. And then a skills checklist. Remember, I said I think you can break it down to be 4 skills. You know, really it's just differentiating, okay? But within that differentiating, you know, you're required to know quite a few rules in there, aren't you? So there's the skills, and I think that's a skills checklist. Do I know what these words mean? If so, you can give it a tick. Then we've got the summary of revision resources. All right, let's turn the page. Let's smash these questions together. Now, what I've done in this first question is I've given you, basically, this has everything we differentiate in it, doesn't it? We've got here polynomial terms, we've got a constant, we've got a trig term, we have a log, and we have a exponential, and we have a root.
Easy.
Now, in a test situation, we're not going to give you a question like this. We would break it up into separate components, but this is a good one for just us to recognise. This is basically all the stuff we need to differentiate. What it doesn't have is things like product rule, quotient rule, chain rule. It's just what functions we're required to differentiate. So, before we can differentiate it, we must express everything in a form ready to differentiate. So there's a few things I'm going to change here. Firstly that, okay, 3 on root x, all right? Now here, you could use the chain rule because we have a function to the power of n, but we can also simplify this using index laws, so we will do that there. And here, I'm just going to pull the 1 on 3 out the front as well. So in my first step, I'm not differentiating, I'm just manipulating the equation to get it in a form ready for us to differentiate. So a third of ln x, remember, whenever you have a number at the bottom, always just bring that out the front. Here, e to the x will become e to the 2x, and then here this will be take away 3x to the negative half. Alright, so index laws, if we have a power to a power, they just multiply together. That's what's going on there. Okay, now we can just differentiate. So, I've got the function, here's my derivative. Derivative of 3x squared will be 6x. Derivative of 6x will be 6. Derivative of 2 is a constant, that's 0, that's going to disappear. And then here I have sine of a function. Sine of f of x goes to f dash of x, cos of f of x. So we're going to have 2 cos of 2x. That negative, that's just staying there, all right? That negative is just going to stay there, and I'm just differentiating that term. That's what it becomes. A third of the third's going to hang out, and the derivative of ln x is 1 on x. You can multiply them through to make it 1 on 3x. Here we have e to the kx. The derivative is going to be k e to the kx. Minus 3 can just hang out. The derivative of x to the minus half x to the minus 3 on 2. Done. All right, we've differentiated every term without simplification. Very good. Okay, so this is, then we've got a first principles problem. We have the function ax squared plus 5x take away squared. Now, This popped up in last year's exam, reasonably similar, and this is reasonably similar to the one to expect in the test. Quadratic, very easy to perform first principles for. Alright, there's no nasty cross multiplication or conjugates required, but we have introduced this A for you. This is just a number. You treat it just as if it were a number. It does not change anything. So we're just performing first principles to this function as if that were a number. So, first step to get our first mark is to put it in the formula. F dash of x is the limit as h approaches 0 of 1 on h. And then we have f of x plus h. I put x plus h into the function. And then take away f of x. Alright, so you get a mark just for putting it into the formula, right? F of x plus h, take f of x. So that whole thing, we will substitute in x plus h, that whole thing we would have got f of x. Okay, that's step one, done. Step two, completely expanded. So I'm going to do this over 2 steps, and I would encourage you to do the same. Where kids make mistakes is when they're trying to rush, they're trying to skip ahead, they're trying to, use their time really effectively, but it's better to do this slowly, better to do it methodically, you won't make a mistake. So we've got 1 on h, and we're going to have here a times x squared plus 2x plus 2h. So when I say slowly, I'm doing the square first, using perfect square rule, and then I will distribute the a. Now, excuse me, what have I done there? Plus 2xh plus h squared. Over here, 5x plus 5h, and then take away 2. And then we'll distribute this negative in here. Take ax squared, take 5x plus 2. Now you absolutely must have f of x here in brackets because that negative absolutely must distribute in order for it to cancel appropriately. Okay, so all I did there was expand it. Alright, I've got one more expansion step to do. I said I'm going to do it slowly and make sure I do it properly. And so that means I'm distributing this a to every term in the bracket. That's all I'm doing in my next step here. Plus 5x, plus 5h. Beautiful. Okay, so this is the checkpoint, right? This is where we know if we're on the right track. So we collect like terms. So formula, expand, now we're ready to collect. I'm looking along. ax squared, ax squared. Everything that does not have a h should cancel. Ax squared, take ax squared. Alright, we've got 5x, take 5x. And we have minus 2 plus 2. Alright, so let's state what we have left. Factorise and cancel h. So this is the checkpoint, right? Everything has a h in it. That means we've done the right thing. 2ax plus ah plus 5. That will cancel. And we can apply the limit. Now when we apply the limit, that means I'm just putting 0 where there's a h. That's going to be that term. We're going to be left with 2ax plus 5. That is our derivative function. Okay, good. That's part A. Find the derivative using first principles. Any questions about that one? Very good. So then, determine the coordinates and the slope when x is minus 2. Firstly, let's do the coordinates. That means we want the x value and some y value. How do I obtain a y value? I take this x value and I put it into the original function. That's going to give me the corresponding y value. So I'm going to put that into the f of x function, f of minus 2. I'm going to put minus 2 into the original function. It's going to be a. Remember, a is just a number. A times minus 2 squared plus 5 times minus 2, take 2. Okay, minus 2 squared is positive 4, so here we'll have 4a, take 10, take 2, 4a, take 12. We can't simplify that anymore. When x is minus 2, the y value is 4a, take 12.
We could do a take 3.
Sorry?
You do a take 3, you can simplify that more.
Sorry?
You could do a take 3, you can simplify that more.
Here?
Yeah.
Oh, no, we can't because yeah, because it's not an equation equal to 0. So yeah, no, that's as simple as it gets. All right, so 4a take 12. That's the y value. We have our y value. All right, we've got the coordinates. We've got a set of coordinates. That's what the first part, and the slope. Now, whenever you do something, all right, part A, part B, hence using what you've done above, we have to use this somehow. This is the slope function. It tells you the slope for any value of x. So when x is minus 2, f dash of minus 2, we're putting minus 2 into the derivative function. We have 2a times minus 2 plus 5. This gives us minus 4a plus 5. And so what this means is at this point, when x is minus 2, the y value is 4a take 12, and the slope is minus 4a plus 5. The gradient, minus 4a plus 5. The steepness of the function at that point. Very good. Okay, that's okay for 2. Good. Now, if you've been doing the Pracky test, you've seen these pop up a fair bit. They're a beautiful question because they allow us to do differentiation and log laws. So, and I've got a horizontal slope here as well. So we have y equals 3e to the 2x, take 1, take away 2x. All right, that's a function we're represented with. Find the exact value of x such that the slope is horizontal. So find the x value given the slope is horizontal. Horizontal slope means the slope is 0. It's not increasing, it's not decreasing. So we need to find the slope function. Find the derivative, make it equal to 0, solve for x. That's all we're going to do here. So we'll differentiate this. All right, the 3 is just going to hang out the front. E to the 2x take 1 becomes 2e to the 2x take 1. Okay? F dash of x, e to the f of x. And the derivative of minus 2x is just minus 2. That's the derivative function. Now, if we're going to communicate it clearly, it's not something we need to do, but it's good math. It's horizontal when dy on dx equals 0, which means 6e to the 2x take 1, take 2 equals 0. All right, the slope function, here I've just distributed, 3 times 2 gives you the 6, equals 0. And now we're just going to solve that equation. Plus 2 to both sides. Divide both sides by 6. Okay, you can simplify that to a third. You do not need to. Okay, once we've got the exponential component by itself, we're going to perform the natural logarithm of both sides. So we'll have here ln e to the 2x take 1 equals ln of 2 on 6. Now, ln e to the x simplifies to x. So ln e to the 2x take 1 simplifies to 2x take 1. All right, plus 1 to both sides. Now, just to be clear, I think it's much better to write it like this than like this. I have seen some people do this, 2 on 6 plus 1. Because here there's a bit of ambiguity. It's like, am I performing the logarithm of that number, or is it just that one? Be clear. It's the logarithm of that plus 1, and then divide by 2. All right, we'll just half it. So you can write it like, there's lots of ways it can be written. Like we can do it like that. We can have it as half ln of a third plus a half. Any of those is absolutely fine. All right, so that's 3. Any questions about 3? Okay, 4. I'm giving a big clue here in 4. And this does pop up in the practice test as well. And the big clue is whenever you're required to differentiate a log function, okay, always look for, can I use log laws to split it up, to simplify it? So our log laws are ln of a plus ln of b is ln of ab. And that's the first one, right? There's 2 others, you can look them up. But that's exactly what we have going on here, right? We have x to the 3 times cos of x. We have this form, so we can split it up into those components. Another way we can express this, ln x to the 3 plus ln of cos x. Okay? And then here, we can even simplify that one using log laws as well. You don't have to, but that's the same as 3 lots of ln x. Okay, we're ready to differentiate. Make sure you're clear, f of x, f dash of x. 3 is just going to hang out. Derivative of ln x is 1 on x. Okay, here it's not ln times cos x. It's ln of cos of x. It's ln of a function. And so the derivative is f dash of x on top of f of x. So ln of a function, the derivative of cos x is negative sine x on top of the function cos of x. Okay, so let's simplify what we've got. This one's a show that, isn't it? It's a show that it's equal to this. So we have 3 on x, take away sine x on cos x, and sine divided by cos is tan. 3 on x, take away tan x, as required, QED. Okay. Good. All right, so we've covered most of the skills. We've got one more to go. We've got y equals sine x on top of cos 2x. Find the slope when x equals pi on 3. Okay, this question, what you have to do is pretty easy. The execution, there's a little bit of complexity involved. Okay, so find the slope when x is pi on 3. All right, differentiate, put x is pi on 3. That's what you have to do. Okay, so let's try it. In order to differentiate this, you have to use the quotient rule. We have one function divided by another. So very clearly define what's u and what's v. And derivative of sine x is cos x. Derivative of cos of f of x is negative sine of f of x. So make sure you get those components correct. Okay, smash it together for quotient rule. U dash v, take away u v dash. And when I'm doing this, I'm not trying to simplify it, I'm just smashing it together for now. We can simplify it later if we want to, All right, but I'm just copying it straight from here. U dash V, take away U V dash, all on top of V squared. That's the slope function. We've got it. We're 1/3 of the way there. Okay. Now I will simplify it a little bit just for when we're substituting in. And I'm just going to simplify here. Minus sine x times minus 2, that's going to become plus 2. So here, cos 2x plus 2 sine x sine 2x. Alright, just brought the 2 to the front and it's become positive. And that's all on top of cos of 2x. And that's squared. Okay, derivative function done. Now what are we asked to do? Find the slope when x is pi on 3. So I'm going to take this pi on 3 and I'm going to substitute it into here. Alright, what are we going to have? We're going to have cos of pi on 3, cos of 2 times pi on 3. 2 times pi on 3 is just 2 lots of pi on 3, plus 2 sine of pi on 3, sine of 2 pi on 3, all on top of cos of 2 pi on 3 squared. Okay, so there's a fair bit going on there. We've put in the pi on 3, and so that means now we know we have to look at our unit circle. I have to go to my unit circle, go what's the x value at pi on 3, 2 pi on 3, the y value at pi on 3, 2 pi on 3, and I'm just going to be substituting them in. So, if you're looking at your unit circle, all right, just thinking, I think I will do it over here. So the first part, cos of pi on 3, all right, if you go to your angle, the x value at pi on 3 is 0.5, half. You can write them up a half if you want, or 0.5, either's fine. But cos of pi on 3 simplifies to half. Okay, cos of 2 pi on 3. All right, you need to be able to follow along with the unit circle. Cos of 2 pi on 3 minus half. I'm getting them right, aren't I? Yep. Okay, good. That's the first part. Then we have a plus, and then I have this 2 there. That's just going to multiply whatever our sine is. Sine of pi on 3, root 3 on 2. Sine of 2 pi on 3, root 3 on 2. Okay, so that's what we have at the top. And at the bottom, we have cos of 2 pi on 3, which is minus half, and that component is squared. Okay, and then we're just multiplying these out. Here I have half times minus half. That's going to be minus a quarter. All right, the top times the top, bottom times the bottom, and it's a positive times a negative, so it's a negative. 2 times 2 is 4, 1 times 1 is 1. That component simplifies to minus a quarter. Okay? Over here, we have 2 at the top, 2 at the bottom, can cancel. So we're just going to be left with 1, 2 at the bottom. Okay, there's just one more 2 at the bottom, and at the top we have root 3 times root 3. That just gives you positive 3. All on top of 1 on 4 at the bottom. I should have made more space. Okay, so we need to simplify this using fraction operations, right? And so we have minus a quarter plus 3 on 2. Minus a quarter plus 3 on 2 on top of a quarter. Now if we're going to add them together, these need to have the same denominator. So I'm going to multiply this one by 2 on top of 2. I'm going to make it as 6 divided by 4. 6 divided by 4 is the same as 3 on 2. They're the same fraction. Now they've got the same denominator. Alright, so that becomes minus a quarter plus 6 quarters will equal 5 quarters. Alright, minus a quarter minus 1 plus 6 is 5. All on top of a quarter. AD on top of BC. Alright, AD on top of BC. That's going to give you 5 times 4 on top of 1 times 4. 4 will cancel. And our answer is 5. So a fair bit involved there, right? Like as far as substitution and processing goes. But it's all we're doing really is multiplying, we're adding fractions together. And there's a question like this in the test. I think it's 3 marks. You know, you get 1 for the differentiation, 1 for the substitution, and then you get the last mark for collecting. Right.
Is there more than one of those?
There's just 1. Yeah, we're only assessing these ones. Yeah. And yeah, this is a pretty good one to do it for, I reckon. All right, so that's a pretty good summary of all of the skills you're expected. If you're alarmed by any of these questions, please make note of it. And when I'm coming around, say, "Oh, can you explain any more about that to me?" Or, but yeah, I think we're pretty happy and ready to go.